Hello, Gnu Radio Conference. Haydn Nelson here with NI and Ettus Research. Good to virtually see you, and welcome to my coronavirus software-defined radio demo bunker here in Austin, Texas, or as I like to call it, my home office. Really, unfortunate we don't get to be there in person, but we're really excited to be back at Gnu Radio Conference. This is the 10th year, and actually this is the 10th year since NI acquired Ettus Research, which is also exciting. And so we're excited to be here again, virtually, if you will, to connect with you and learn about, look at the great technical program that's going to be had, and virtually show off some cool demos. I've set up all my sweet SDR gear here behind me, so I don't normally keep it like this. So today, what I wanted to discuss with y'all, or share with y'all, I wanted to share a few kind of updates from the Ettus Research side, and bring in some of our new faces and some known faces from the software-defined radio R&D team to talk about some of the latest enhancements to the USRP hardware driver that we recently released. So, well, here, let me start by sharing my screen and talking through a few updates with the Ettus Research side, and then we'll bring in some of the R&D folks. Here we go. Hit share. All right, great. So today, I titled this talk "A Conversation with the Software-Defined Radio R&D Folks," but couldn't get through this without giving y'all a quick update on some of the things that we've been working on to benefit the SDR community out there. And one thing you will notice on this slide is this little green thing down here. And so I won't spend much time here, but you may have noticed that National Instruments went through a major kind of corporate identity change, I guess, if you will, and people may have already known National Instruments as NI, and we've kind of renamed the company officially to NI, and that was really around the notion that National, we sell more than just in the United States, and Instruments, we sell more than just instruments. Our USRP devices is a really good example of that. They're software-defined radios, not instruments, and so it's kind of an acknowledgement of it. The companies needed to evolve the way we're perceived and some of those aspects. Not probably that interesting to the average engineer, but that's kind of the reasons. The cool thing is it's green, so I actually was really excited to see the choice of green, because everyone kind of knows Ettus Research has used the green colors. So, NI finally came to its senses and picked the right colors, I guess, so to speak. Anyway, so this year at GNU Radio Conference, we have the NI and Ettus Research team has a couple new faces and a couple known faces and several good technical talks. We're really proud to have been a major contributor to this conference since its first one in 2011, and always trying to contribute to the technical work that is this content that is attached to this conference. And it's always a thing we're really proud of is being able to add back to the community with helping people building their wireless applications and share some of the great work around SDR. So Tuesday, I encourage you to, we all know Martin Brown. He's going to be talking about some of the updates to GNU Radio 3.9, the de-swigification, and how they're removing this, some tooling from GNU Radio 3.9. A new face to the group is actually a gentleman named Aaron Rossetto, who's a principal SDR Software Architect. I've worked at NI for about 10 years, and when I started, Aaron Rossetto was one of the senior software guys at that point at NI, and so he's been in software development for many years. He's a phenomenal software engineer, and we'll be sharing some of the work that he's been doing with the Python API in connection to the RFNoC on chip framework. And then Martin Brown will return on Thursday, talking about some aspects, connecting the analog world to the digital world in his talk on How Strong Is My SDR Signal. And Abay Samant is our chief software engineer for our aerospace defense systems R&D team. Now kind of with that changes to NI, we've organized into different industry business units, and we're investing a lot in defense technology, and SDR is a strong part of that, as well as some of the commercial wireless side. Abhay joins us from our aerospace and defense team, and he has a strong background in those applications. And of course, wouldn't be a GNU Radio conference without our known and loved workshops. So if you haven't already registered, we're starting these on Tuesday and on Friday. We're only doing the Fpga workshops this year, where we're going to be walking through how to use the RFNoC framework for you to, essentially build your wireless application using Fpga technology. And so we have a number of great experts coming in. On the right, a known face, Jonathan Penlam, who was one of the original RFNoC architects and is a known SDR expert. Aaron Rossetto, also on the software side. Wade Fife, who will be joining me here in a moment, is a principal SDR digital engineer. And this last picture here, I can kind of highlight it. We believe this is the best image representation for Anil Pandya that we have at Ettus Research. We believe it's very representative. It's what we could find, and so this is what we believe Anil Pandya looks like in the wild. And of course, he has his trusty USRP in his hand, as we expect him to always have in his hand. This image, courtesy of Alex Wiglinski from WPI. And so Neil will be joining us. And so one of the things this year we won't have is the GNU Radio Workshops. And so if you guys any of you all came to Huntsville last year at GNU Radio Conference, we actually had to expand to have 2 additional sessions of the GNU Radio Workshops for new users, because we had so much demand for people to learn, just getting started with GNU Radio and the USRP. So that's a very popular workshop. This year, we're only focusing on the Fpga version of that, so we are not conducting the USRP GNU Radio Workshop. But fear not, we are. So some of you may have remembered me getting up on stage last year in Huntsville, and I showed you a picture of my Texas redneck truck where I bolted a USRP onto the roof rack and was talking about how much fun I was hacking with my USRP out in the wild. I actually, through that process, I built some kind of introductory coursework. Well, we've taken some of that work, as well as the GNU Radio workshop that Neil has been executing at GNU Radio Conference for years, and built some digital on-demand modules. Now, we've hosted this on the NI learning platform, so you have to go to www.learn.ni.com/training, create a profile, log in, and search for using open source tools on USRP. And so this course is free. It's ready to work, stream today if you are a new user. It'll help you get started with setting up a system with a USRP. You'll also be able to get started using GNU Radio, as well as do some basic SDR applications. Now, there are a number of really good tutorial tools on gnuradio.org that they've actually revamped this year. So if you are a new user, I recommend you look there. This is yet another resource for you. We do plan on expanding this course body of work by the end of the year, where we're going to be walking through building IP blocks and then connecting those to USRPs and doing things like performance tuning of streaming application, as well as taking our Fpga training and making it more digital on demand. Here's hoping we'll be able to do these things in person in 2021, but this is really to try to help enable you, our customers, to continue to up-level your skills and get started if you're a new user in this time where we can't connect in person. So that's something we've done for the community, and it's all free at this point. And but you have to go to this web address to get access to this courseware, and it's ready today. So we're still selling radios. We're I don't have any brand new hardwares products to announce today. I guess, B series, X series, E series, and N series. Last year we launched the N320, which you can see I have a, 1 gig of sample per second running on across 4 channels on some N series right here behind me. But one of the new radios is the RX310, and that's basically a repackaging of the X310. So if you have needs for like a rugged enclosure for an X310, that's something that you can reach out to us on. But the big thing is UHD 4.0, and so UHD 4.0 is released, and we're really excited about this. This was no small feat of engineering. Our R&D team has been working really hard on this. Martin came and talked about some of our plans around it last year. It's a major enhancement to the USRP hardware driver, with improvements all across the board. I can't remember how many lines of code it's changed, but we've improved performance, usability, flexibility, documentation, and like more than just the features, but like testing, like we've improved the quality of the code. And so with that, like, let me stop sharing my screen and get out of my marketing PowerPoint here. So you're probably all asleep at this point. Let's go ahead and bring in some of the folks from our software-defined radio R&D team. So if you gentlemen care to join us on the call here, we have some of our folks from R&D. Thank you all for joining me. So I guess what I wanted to start with today was was talking about some of the major updates and to the driver. I'll start with you, Wade. I know that you're a principal digital engineer on the SDR product line with how long have you been doing digital design again?
It's been since the beginning. So yeah, I'm a digital hardware engineer. My specialty is FPGA design, and I've been doing that since I graduated in 2003.
Oh wow. Yes, I used to be an FPGA designer at one point in my life, and then I ended up getting into the business and marketing, which is lose a lot of credibility there, I guess.
Yeah, less fun.
Yeah, it's less fun. It is less fun. So on the FPGA side, so one of the major changes at UHD 4.0 was some enhancements we did to RFNoC, and like some of the endpoints. Kind of what are some of the major things that you worked on, in that development?
Yeah, so let me start just by giving a little quick introduction to RFNoC for anybody that might not be familiar with it. But sure. RFNoC is our RF network on chip. So it's basically a framework that we've developed that allows you to do high throughput DSP applications on our USRPs. So one way to think of it is we provide all of the plumbing and the infrastructure for your USRP radio to work, and then you can add your own IP to that in order to enable your custom applications. And so as far as things that I've been working on, so again, my specialty is on the FPGA side. So I've been focused very much in the guts of the Verilog and the code that runs on the FPGA. So we've been using RFNoC for a long time. So we've learned a lot, and we've been able to apply a lot of those lessons as we've kind of re-architected things in UHD 4.0 for an improved experience. So some of the things we wanted to do was scale the total system bandwidth that we have available. So you mentioned the N320 that was introduced last year, 250 megasamples per second. And so with a product like that, we're kind of starting to feel constrained by the current architecture. So we've actually wanted to improve things so that we can go well beyond 250 megasamples per second, beyond a gigahertz per channel is kind of what we're looking at. So, and I can talk a little bit about how we're able to achieve that. We also wanted to be able to scale the number of RFNoC DSP processing blocks that we can have on a single FPGA. So we've made some changes to allow for that. And we also wanted the user to be able to have more trade-offs, right? To be able to trade off things like throughput versus latency, or flexibility versus area, so that they can make educated design decisions to optimize the FPGA. Because you want to get as much out of that FPGA as you can, because it's kind of a fixed resource. And also we wanted to improve the customer experience. So a lot of work has gone into tooling improvements and making it easier to create your own IP blocks to put inside the FPGA.
Yeah, because I remember was there any changes to because we still have the concept of, within RF network on chip, it's this kind of infrastructure framework where there's like this network crossbar. So I recall, like, in the 3.0 version, it had a limitation of 16 blocks. That's somewhat has a higher bound now at this point.
Yes, so that's specifically one of the things we wanted to address. So in previous generation of RFNoC, all of your blocks would connect to this crossbar, and each block would have a 64-bit port that connects to that crossbar. So you can imagine, first of all, that port, that's going to be a bottleneck at some point. eventually you get to the point where 64 bits is just not enough. And
Mhm.
we also had problems where if you had multiple channels, then those multiple channels in a block would share that 64 bits bandwidth. And so one of the things we did in UHD 4.0 is to make the width of the port of each RFNoC block configurable. So instead of 64 bits, you can make it 256 bits or up to 512 bits is what we currently plan to support, which gives you a tremendous amount of bandwidth. On top of that, you're not limited to having a single port. So if you have multiple channels, you can actually have a separate port per channel. So
Mm.
each channel can have its own dedicated bandwidth, which is great. So now back to the crossbar that you mentioned. We want to be able to fit more blocks, and so what we did is we introduced this concept of static routing, because what we found is when you basically when you first initialize the USRP, you set up the routes in that crossbar that connect one block to the next block to the next block. And what we found is that most people, they do that configuration once, and then the routes stay the same for the duration of the application. So instead of putting all of that traffic through the crossbar, what we did is we created a static section where you can actually connect the blocks end to end without going through the crossbar. So that reduces the requirements for the crossbar and reduces the number of blocks and things that need to actually connect to it.
Mm.
So on top of that, there's some additional benefits to removing things from the crossbar. If you have the blocks connected directly to each other, you no longer have the need for all of the buffering that currently existed in our RFNoC blocks. So you can actually pull out a lot of that buffering, that memory, and a lot of the logic that implements the RFNoC communication protocol and flow control. We can pull all of that out of each RFNoC block and then put that into a separate block that we call the stream endpoint. And so now all of your blocks can be connected directly to each other without any of that logic in between them. And only at the end of the DSB chain do we need this streaming endpoint that has all the buffering and implements the high-level flow control for communication on the network.
So presumably that could have benefits for, like, obviously bandwidth, less logic in the FPGA in certain instances, probably. It's
Yes.
FPGAs are a finicky animal. You pull one here and something else, becomes another constraint, and maybe even latency, because I know, like, certain applications, latency is something that is really critical in, like, certain wireless protocols and, like, radar applications, things of this nature.
Yeah, it's specifically to add to that in terms of latency. So another change that we actually made was to separate the data paths and the control paths in the FPGA.
Hmm.
So previously, all of them. Let me step back and define what I mean by data path and control path. So the data path is the RF data samples for your application, just the RF data.
Hmm.
By control, what I mean is the register reads and writes to the RFNoC blocks to configure them or to control their behavior or check on their status, those kinds of things. And previously, that traffic was over the same channels. So your control traffic would actually eat away from your data throughput slightly, and that the data traffic could actually affect the determinism and the latency of your control traffic. So now those two paths have been separated. So you can actually have control traffic moving around on the FPGA completely independent of the data flow, and which actually opens up some really interesting applications where, consider, for example, you have an RFNoC block that's actually controlling or tuning another RFNoC block in real time. So this architecture allows you to have a really tight control loop between those RFNoC blocks without being affected by the actual data that's flowing between them.
Interesting. I can think of, like, applications of, like, avoiding interference and tuning things around, in real time. It'd be kind of interesting.
Yeah.
Well, yeah, no, that sounds cool. I'm excited to see what people in the community will use some of these new enhancements for. That's one of the cool thing about our customers. There was building something really interesting. So, but I mean, one of the things was the bandwidth enhancements, and that to me is streaming, and that's been a major request from a lot of customers, is, like, streaming performance. Like, a lot of times, pulling data onto the FPGA and doing real-time signal processing, but oftentimes people want to move that data to a host machine and on the CPU side do some processing, and that's really about kind of streaming. So I'll bring Ciro. You're a long time NI, or actually I was at NI, started 10 years ago and sat right next to you for whenever I was a software engineer, and so you've been at NI for what, like 20 plus years, was it?
Yeah, that's right. It's 21 years now as a
Oh man.
software engineer.
Okay, well,
A lot of those years in RF instruments, both RF tests and now SDR.
Okay. Yeah, it's, we're excited to have guys of your longtime experience on the SDR R&D team. And I know that you worked a lot on the host side streaming architectures for UHD 4.0. What were some of the enhancements that you worked on and you think customers will, like to hear about, I guess?
Yeah, for 4.0, we basically rewrote most of the streaming paths there in UHD for the devices that support RFNoC. And the primary driver for that was obviously getting more bandwidth. Also, some of the changes that Wade talked about require some of the changes that we were making, like separating the control and data paths. That was also beneficial, I think, because the old streamer code had become a little bit hard to maintain and understand. So besides rewriting it and kind of looking for all the different places where we had unnecessary overhead, like removing, trying to minimize the number of virtual function calls, for example, try to remove the use of shared pointers in that code path, things like that. We also made a number of architectural changes that made our performance better. Our packet format is leaner and faster for us to decode. We also moved, for example, in streaming applications where you utilize multiple threads, we moved the flow control part of the streaming into the thread that is closer to the hardware, which allows that thread to run unimpeded from the application thread and hopefully get you better performance.
Yeah, I had the distinct pleasure of working with UHD 4.0 with some of the apps engineers. We have a nice, if anyone's watching this, we have a nice demo of that running at full rate on an N310 in our kind of virtual demo booth in a video. So I encourage people to go check that out. That's some of your work, getting to be in a video studio. So I know that because that wideband streaming has been a big request, but other people, like last year, I know we talked about the data plane development kit. Michael, you worked on some of that as well, right? The DPDK aspects in testing.
Yeah, I was a little involved with some of the testing. I admittedly, other members of the team did most of the testing, the actual testing, but yeah, DPDK has really given us a boost to get to the streaming performance numbers that we've been looking for a long time, actually. And we had to gain some experience with DPDK because it is a very low level thing. It's down at the kernel level, and even the hardware configuration can have an impact on DPDK. But once we got that nice and stable, we got some really good performance numbers out of a lot of our devices, especially the ones with the higher bandwidths. Looking at the X300, N310, and N320 devices, we were able to push those pretty much to full rate on all channels, and that was very exciting to get there.
Yeah, I always think it's like, we enable all this great streaming. It's like the old adage, you can't hook a fire hose to a garden hose type of thing. So, I think some of those improvements that Ciro is talking about on the host side make that possible, that for pulling that data, consuming it, and doing something meaningful with it on the host, is probably more possible now than ever, without having to have like a monster supercomputer. Probably need some pretty powerful computing on the host side. So I guess, are there any other points that you wanted to make about some of the streaming enhancements, Ciro? I wanted to ask Michael a few questions about the test framework, actually.
I think I covered most of it. One thing that I remembered, we added a way when you have multiple network interfaces Previously, UHD would assign for you what the interface, what channel goes through each interface, and you didn't have much control over that. So in UHD 4.0, we still do that, but we have a way for you to select what interface to use for each channel. So if you have one streaming path that is lower than another, or if you have multiple streaming channels and you have a few that are slow, you can combine them into one interface and have the higher bandwidth channels going through a dedicated interface, so that you can balance your streaming better.
Yeah, we had to do that on that demo video that's in our booth, and it was a dual 10 gigabit Ethernet path, and I believe we used that feature where you can kind of connect multiple streams together. So no, that's cool. Thanks for sharing. So I mean, I guess the last topic I wanted to highlight is Michael West. Everyone in the community, if you don't know Michael West, you will know Michael West. You've been with Ettus Research for how long, Mr. West?
7 years now, working on usurps, and it's been a great ride.
Yeah, well, it's like we actually, I wrote a blog for the conference, and I was talking about how the Gnu Radio conference is 10 years. Ettus Research with NI is 10 years this year, so it's kind of a neat thing. You've been here for most of that,
yep.
As part of the SDR team. So appreciate all your hard work. And this in UHD 4.0 was. This is open source, and I think open source kind of forces us as software engineers to keep the code clean, because people are going to see under the hood. You don't want to see any of the source code I wrote when I was in R&D. It wasn't very clean. But another really, really important thing is testing. And I think I was talking with you and some of the team members about some of the enhancements to testing to ensure it's, stable when it hits the repository. So can you talk through some of the body of work that you've been working in that direction?
Quality has been definitely a key for us on UHD 4.0, and testing is definitely a key part of that. So, I mean, first, let me just go over the challenges we had to face. I mean, we had 831 commits to the code, major architectural changes, including RFNoC, including the streaming architectures. We moved to an embedded systems. We moved to the Zeus branch for open embedded. We have more devices than we've ever had before that we actually have to keep stable and have to keep functional. I mean, between the N200 series, the B200 series, X300 series, E310, E320, N310, N320. I mean, we have so many devices. And we also decided to integrate the Fpga repo back into UHD. We are, at the same time, we're supporting now a multi-usurp API and an RFNoC API. And we're trying to support those on both C++ and Python. So amidst all these massive changes, we're still trying to maintain stability and quality. And despite all of those challenges, we were able to actually increase our overall test coverage to keep all of our platforms very stable. We've fixed many of the longstanding issues. You've mentioned all the streaming performance enhancements we've done. So we're able to stream at full rate on many of the devices. We made substantial changes on the TwinRx RF performance. So we've got rid of a lot of the RF noise on there. We had a spur at DC that we got rid of. We added a power calibration utility in this. And when the release finally does come out for 4.0, which should be very, very soon, if not by the time of GRCon, we're updating also the SDK for the B200 firmware and bootloader to bring that more up to date. So we've had a lot of challenges, but we've had a lot of wins. And I think that people are going to have a very good experience with 4.0 and the quality going forward.
Yeah, I was always, whenever I was in a software developer in R&D back 10 years ago, I was always impressed with those labs of automated test suites. It's the testing doesn't get as much glory, but whenever something doesn't work right, then you're upset that it wasn't tested right. So fortunately, we know a company that knows a little bit about software testing.
And obviously this is an open source community, and I just want to reiterate that The Gnu Radio community has actually fed back in, and the things they've reported on the mailing list, the pull requests they've put up on our public repos, all of that stuff we have actually pulled in and incorporated into UHD 4.0. So the contribution from the community has made a big difference as well. So, you know, a big thanks to everybody in the community that has contributed.
Yeah, that's a great point. You know, I'm lacking. I haven't put in any pull requests. So I appreciate everyone's time, and you know, go ahead and get there, Mike. Appreciate it. I was getting a little bit of an echo. So I'm excited that UHD 4.0. I mean, we're slotted to have it released by GRCon. So, you know, by the recording of this video, it should be released by then. It's you know, about a week and a half away. And we're excited about seeing what y'all are going to do with the Fpga, with some of the streaming, and there's a number of other applications. There are going to be a number of you know, chances throughout the week to connect with us. So, you know, come to our chat room in Matrix and reach out. We're happy to set up a meeting and sit down and talk through, you know, how we can help you with your wireless application. Just kind of connect with some of our expert. It's all hands on deck this week for us at Ettus Research and NI. We're excited to again be here at Gnu Radio Conference, albeit virtually this year, and we look forward to the conversations this week and seeing you all again in person next year. Yeah, thank you for your time today. And thank you, gentlemen, for joining me.
Thank you.